Excuse me. Okay, so what I should do is just open the other one. So there's the other one. Okay, so... Whoop. Sorry. Oops. Let's pause the music there for a second. Let's go to... Okay, so what we're going to do is redo this entire function, do minion AI. And it's going to handle the minion and the minion and particle projectile. That's fine too, either way. Projectile AI. Okay. I still like the way that I have this set up with in low I, in high I, and then the in type AI, so yeah. That was pretty good. Okay, so what we want to do is kind of redo the pseudocode right here. We're going to do pseudocode, then we're going to change the function to actually do the pseudocode. I know I've got a copy of it there, but let's just comment it all out as well. I know I should just start over with another, just save the function, call it do minion AI2, but we're just going to start over because that one doesn't work. It was a good try. A for effort. Okay, let me turn down the music in my ears so you guys can hear the music. Okay, so the first thing we want to do here with the minions is define all the states of the minions. Okay, so we're going to have a minion state 0. Okay. Now this state will do one of two things. It will either move to the nearest waypoint, or it will move to the nearest enemy. Then also, in order to change to state 1, it will check if within firing range to launch projectile. Okay. And now if it's within the firing range, then change to state 1. Okay, and then minion state 1. What that's going to do. Okay, and then here's where it gets interesting and why I was a little bit doing it wrong. Because the minion, we don't want the minion to take full control of everything while the projectile is launched and headed towards the target. Excuse me. So we're going to also have projectile states. So minion state 1 is going to do this. Minion state 0. All minions are initialized to this state. Same with projectile state 0. All projectiles are initialized to this state. Okay. In the code, we'll actually get a little bit more. We're going to take all these comments, we're going to implement them in the code, and then we're going to expand on them and make them work. We're totally starting over from scratch on this, and it's going to go relatively quickly because we have all the stuff in place to do this. We just kind of got a little mixed up. So Minion state 1. What happens when Minion hits state 1? Okay, so it's going to launch the projectile, and it's going to go set Minion velocity to 0. So it's going to stop. And then also, even though it's just launched the projectile, we're going to check if within firing range of an enemy minion. Okay. So at this point, though, we've already launched the projectile. So checking within, if we're still within firing range of an enemy minion, is to check if we're going to change back to state 0. So that's it. That's all we're doing for the minions. That's the AI for the minions, at this point anyways. We could add more later. So all minions are initialized to state 0. Move to the nearest waypoint. Move to the nearest enemy. Check if within firing range of an enemy minion to launch the projectiles, change to state 1. And perhaps I'm also leaving out the fact that we're going to initialize them initially. And how is that different from a minion re-entering state 0? See, like if we change back to state 0 over here, there's a different, because it does do a little bit of a reset, but it doesn't change everything like this initialization, the first initialization. So maybe we could go a little bit more into detail on that, but at the moment I'm not going to. Check it. So then we're going to move to the nearest waypoint or move to the nearest enemy. So this is merely a sight range, okay? And then this is a firing range. So those are two different ranges. Just wanted to make the distinction there. And launching the projectile now, because now the minions are complete. So when we're in projectile state 0, okay, so initially it's invisible and not moving. Okay, it doesn't really matter if it's moving because it's invisible, so it really doesn't matter. Okay. So that's pretty much it for the projectile state 0. Sorry, we're going to move down here to projectile state 1. Because the projectile state 0, there's nothing that the projectile does to move itself into another state. Only the minion will be able to, at least to move it out of state 0. Okay. So only the minion will be able to move the projectile out of state 0. That's an important distinction here. Okay, so projectile state 1. So when the minion enters state 1, it becomes visible. Okay. It also, the entire time, as soon as it's active, it move to target. So the target is not going to change. So move along trajectory. Okay. So first it will acquire a direction toward the target. So maybe we should do that. Move. It becomes visible. It acquires a direction toward the target. And then we'll save that part. And then it changes to state 2. Okay. Projectile state 2. See, here we go. So it's moving along the trajectory until it hits the target or goes off screen. So if the target moves, something happens. It moves out of range as the minion projectile closes in on it. It's just going to go until it goes off screen. Okay. So if it hits the target or goes off screen, all we're going to do is so I forgot, up here we're also going to set launch position and acquire a direction. Okay. Move along trajectory until it hits the target or goes off screen. So hits the target or goes off screen. If it hits target, can we get a the? That's fine. Or goes off the screen. Okay. Alright, sorry. If it hits the target or goes off screen, then what we're going to do is change it, reset to state 0. Okay, so looking at this, is there anything else that we want to do? This is pretty much it. I'm going to finish my banana and meditate on this. Okay. So here's what we're going to do with all this. Some of this stuff we have already done. In fact, I think we've done every bit of this stuff except for gotten it in the right order, gotten it in the right priority, and understood that understand that the minion changes the projectile to state 1 here. So really what we could do is we could add another state for the minion. Because what we want to happen in state 1 is launch the projectile and then set the velocity to 0. But then this is what we want to happen in state 2 because we don't want to continually check. So let's just see. And then set minion to state 2. So what's going to happen when a minion is in state 0 and it's moving to the nearest waypoint, it gets within sight range, it sees an enemy, changes direction, and moves towards the enemy. Oh, incidentally, also avoiding colliding with other minions. Not that big of a deal, but we want it looks way better when the avoidance is in there, even though it makes them a little twitchy. But for now that works, and we will make it look pretty later. We just got to get this working first. So here we go. Moving to the nearest waypoint, moving to the nearest enemy, avoiding colliding with other minions, checking within firing range of an enemy minion to launch the projectile. So if it's within firing range of an enemy minion, that changes the state to 1. At which point it launches the projectile, sets the projectile to state 1, sets the minion velocity to 0, and sets the minion to state 2. And the only thing state 2 is going to do is check if still within firing range of an enemy minion. So let's just say check if within firing range of an enemy minion to change back to state. If not, change back to state 0. I think that makes sense. Okay, and then as it sets the projectile to state 1, again we're in state 0, invisible, not moving. State 1, become visible, set the launch position, acquire direction towards target, and change to state 2. Then, immediately it's going to go from state 1 to state 2. It's going to do a little quick set there. And then it's going to move along the trajectory until it hits the target or goes off screen. If it hits the target or goes off screen, reset to state 0. Okay. So we need to check, because what we want is for the minion to continually fire. Okay, so check if within firing range of an enemy minion. If not, change back to state 0. So if it stays within range of the enemy minion, we also want to check if the projectile has reset to state 0. If so, and we're still in the state of 2, if so, launch it. Launch projectile. Set projectile to state 1. Okay. That's where we're getting to the good part right there. So that's it. So I noticed when I went over it again, I expanded on it. So let's go over it again. Let's go over it again. Okay. Let me meditate for a second. When all of life go out of focus, you return to a basic of life. What, pray? No, breathe. No, breathe. No, life. That's a Karate Kid reference. One of my favorite ones. I should probably watch Karate Kid. Okay, not bad for the first 20 minutes of stream. Let's go over this again. Okay, so the minions. State 0, they're all initialized to state 0. Moving to the nearest waypoint is what state 0 drives them to do. Eventually they get into the sight range, moving to the nearest enemy. That changes their direction. Okay. Also avoiding colliding with other minions. Okay, very good. Check if within firing range of an enemy minion. Okay, if we are within range of an enemy minion, launch the projectile. Okay, change to state 1. So we don't need to put this here because the projectile is launched in state 1. So here we can just put up here, change to state 1. Just, I guess we're deleting a line, I guess. That's cool. Okay, Minion state 1. Launch projectile. Set the projectile to state 1. Okay. Well. Set minion velocity to 0, and then immediately set to state 2. So I guess I've never really done state management before, so I guess thinking about it like a state where you just do some things, you don't do any checking, and then you change state immediately. That's kind of like an initialization for the state. So basically state 1 is an initialization for state 2. Okay, that's kind of cool. So in state 2, we check if we're within firing range of an enemy minion. If not, change back to state 0. But that leaves the projectile doing whatever it's doing. And then check if the projectile has reset to state 0. If so, launch the projectile. Set projectile to state 1. So as long as the minion is in state 2 and it stays there, it's going to continually check to see if it can refire the projectile. Okay, that makes sense. Okay, and so set the projectile to state 0. So they all start, again, projectile all starts at state 0 here, invisible and not moving. Doesn't matter where it's at. If it's invisible, that's fine. Then the minion will set it to set the projectile to state 1 when it launches. So at that point, the projectile will become visible. We'll get a launch position, acquire a direction towards the target, and change to state 2. So that's the initialization for state 2, and the projectile is going to stay in state 2. Excuse me. So it's going to move along the trajectory until it hits the target or goes off screen. Excuse me, if it hits the target or goes off screen, it resets itself to state 0. Golf clap. Golf clap, Jeff. Do we have a golf clap? Is there a golf clap we can get? I'm just going to look. Let's see. This has been a while. Yes, I'm on YouTube streaming YouTube ads. Yes, here, you've seen it here.
I tell you, Carl, this is the last year we throw trash. You said that last year. Yeah, but this year I mean it. You meant it last year. Hey, Carl, is this yours? Nah, it ain't my color. It's a bra, James. Look at this smut. Well, if it isn't the South Bay's finest. What happened, Mike? They take away your rooms?
You see, this is the kind of scum you're gonna have to get used to around here. Jeff's new to the force, so I'm giving him the tour. He's also my new partner, so you're gonna be seeing a whole lot more of him.
Wonderful.
Yeah, you're gonna like it here, Jeff. The air's clean, the women are beautiful, and the shifts are short. You know, most of the folks here in Las Playas are hard-working, with a future in mind. With the exception of these two clowns, they're part of the Don't Let This Happen to You crowd.
I don't think I've ever seen this movie.
A word of warning, my garbage-toting friends, from your friendly neighborhood peace officer.
Where's the golf clap?
I've got my eye on you both. If you're not breaking the law now, the smart money says that it's only a matter of time before you will. And you can bet that last dollar that my ass is gonna be there to make the bust.
Golf clap? Golf clap.
Oh, there we go. Let's get it again. Most replayed, 140. Oh, I should have looked at that. Okay, we're saving that. we're queuing that up and saving it. Okay, let's do this. Here we go. Okay. We gotta earn the next golf clap. Ba-da-dum, ba-da-dum. So do we, I mean the minions, so it would be good to verify the initialization. I'm sure that it happens, but let's, yeah. And then it would be good to make a note and a comment in this function. Okay, you can tell I'm really just microscoping this thing out. Because this is not the, this is just the beginning into the AI that I'm going to put into this game. I'm super excited for this. Here we go. Here we go. So this sets up the enemy minions, player minions. Okay. So the minions are initialized here. And this just takes care of all the drawing stuff and all the fun stuff. Oh, computer. Fail. Complete fail. Complete fail. Complete fail. Alright. So, in position, color, type size, rotation, text ID. None of that has anything to do with... Okay, so let's look again at this. So here's the player minions, enemy minions. And then the state is set to 0. Okay. And the velocity is set to 0. The projectiles are initialized. The rotation, start X, start Y. It doesn't matter. I think I was just... This is all for debug purposes, so... So here we can also initialize shoot, what's the projectile variable? Projectile underscore velocity, right? Okay. So M state. Okay, so they're all going to initially start at 0. The velocity will be 0. This takes care of all the other stuff, which we can really just set all this stuff to 0. For the purposes of debugging and previous, we used this, but now we're not going to, so we can just do this, do that, okay, and we don't need these. Oops, this is a vector 2. Don't you give me that squiggly. No. Okay. So that takes care of the projectile and the Minion initialization. That's good. So let's go up here. We verified this. Okay, so in D&D, init, data, minions and projectiles are initialized to state 0, velocity equal to 0. There, that's fine. Okay. So let's do just this. Move to the nearest waypoint. Since minions are all on state 0, first of all, we're going to borrow all this code. So far this code's pretty good. And I think, so like I said, a lot of this stuff we're going to do here, so find the nearest, move to the nearest waypoint, okay? So how do we move to the nearest waypoint? Okay, the first step is to loop through all the minions. So minion state 0. Okay. And move to the nearest waypoint is going to be the first thing we do inside there. Also these things, so let's move those in. Okay, let's also do if this minion dot m state equals 1, we want to move these things in there. Okay. Then if this, I know I could copy and paste it, but it's easier and quicker to do this. Plus, it kind of this kind of reinforces everything I'm doing instead of just. This is really. Well, it's cool. Okay, so now we have all of our kind of pseudocode here. And then the projectiles. Okay, so if projectile, if I can spell it. So the projectile is going to be also, wait. Oh, that doesn't work. Yes, it does. If projectile underscore vel sub I dot m state equals 0, we don't do anything. So state 1, we're going to jump to state 1. changes to state 2. I can put that in right now. Projectile velocity sub I dot m state equals 2. I can do that right now. Projectile. And this one right here, pretty easy right here too. This underscore minion sub I dot m state equals 2. Set minion velocity to 0. This minion sub I dot mvel equals glm vector 2 0. That's pretty easy too. Projectile 1 become visible. Okay, that part we can do right now. Projectile wait, it's not that. It's the part where I go right here. So D&D block 229 plus I D type equals 3. Oh, that makes it invisible. Hold on. Actually, resetting it to state 0 there's only one time when it needs to be set to invisible. So this makes it invisible, and projectile velocity I dot m state equals 0. This is within the if statement, but yeah. So for now we'll comment that out. And that, but and so state 0 we're not going to do anything. So if the minion goes into state 0, there's not going to be anything to do. It's just, and we're going to set it to invisible, so it's not going to be, okay. And so when it comes out of invisibility, this is going to be the random GL float. Whoops, what are we doing? GL float, random. So that's going to be 0, 1, or 2 right there. So we're going to change the type to 0, 1, or 2, which is those different colors of laser. Okay, the easy stuff is done. From here on out, be dragons. Actually, the easy stuff is done. Let's do this. All right, that was good. Gave myself a golf clap. I really like that. Okay, enjoy the music. I am going to take a quick break because that was a good setup. Okay, I did a round of dishes, and yes, that's what we do on Game Dev Breaks, is we do a round of dishes. Thank you. Welcome to the lifestyle, folks. So, okay, so we have this. Okay. Exciting. How long was my break? What did I do? Oh, about 5 minutes. 4 or 5 minutes, okay. Okay, so far this does nothing. Like, I could run this and the minions will just... I don't think I broke anything, but the minions are initialized to state 0, which does nothing. The projectiles are in state 0, which does nothing. So let's run it and see what we get. Should be invisible minions, or invisible projectiles. The minions are frozen with initializ... Oh, looks like the projectiles are drawn. They're not invisible. So in order to make them invisible, hold on, let's go, that's good though. Let's go into the projectiles down here. They're not invisible. Okay, so they make the points there. Init particle group. Init point. Okay, so the init point doesn't create anything. So set, I'm so glad I did that, state to invisible. So now this is where we go back to our other code that we have up here. Because this part here, when you set them to 3, they become invisible. So let's go, where was I just at? Set state to invisible there. So we're going to set it to 3. Okay, now let's try it. Okay, now they're invisible. We know they're right there. But yeah, and these guys are all right here. And I just initialized them to like a random, I was doing some debugging, so okay, there's that. Obviously when they start to head towards the first waypoint, or how the waypoint system works. Okay, so far this is very good. I'm okay. I should pull open the golf clap, but I'm just not wanting to pause the music, so okay. Move to the nearest waypoint. Move to the nearest enemy, avoid colliding with others. Set launch projectile. Set projectile to state 1. Oh, this is pretty easy. Projectile velocity sub I dot m state equals 1. So minion state 1 is all programmed. We're ready for state 2. Check if within firing range of an enemy minion. Check if projectile has reset to state 0. So if, and this is a minion, okay, projectile velocity sub I dot m state equals 0. Do something. Okay. If it is launch projectile, set it to state 1. Oh, we can do that too. Projectile velocity sub I dot m state equals 1. Okay, we're getting further. We added some stuff up here, did some stuff here. Okay, set launch position, acquire direction towards target. Okay, good things. Change to state 2, that's already done. Okay, move along trajectory until it hits the target or goes off screen. If it hits the target or goes off screen, reset to state 0. Reset to state 0 is already there, but it's inside the if, so I've commented it out. Okay. This is a large chunk of code that's pretty complicated that I'm actually feeling the most comfortable in my life of ever approaching a large chunk of code like this. So that's kind of cool. I'm feeling kind of good. Golf clap. Hey, thanks for the like, whoever's watching, lurking, whoever came in while I was on break, maybe. Let's see. So now let's borrow more, steal more of this code back. Let's get it back. So check if minion is in recognizable state 0, reset laser, okay, state 0 initialization. Search for enemy units within sight range at the top of each frame. Is that what we're working on? Move to the nearest waypoint. Move to the nearest enemy. Avoid colliding with others if within firing range of an enemy minion. Okay. Okay, I suppose an optimization here would be if we're, I mean, immediately we could check if we're within firing range of an enemy minion. We could even have a separate state for moving to the nearest waypoint, and then if it's within sight range of an enemy, moves to the nearest enemy, and then if it's within firing range. But we're still going to be checking always to see if we're within sight and firing range. Okay, so it's just that's this state kind of is like 3 states in one. So check for the nearest waypoint, check for the nearest enemy in sight range, check to see if you're in firing range of the enemy minion, and then the added avoid colliding with other minions, which really doesn't need to be a part of state 0, but state 0 is currently the only state in which the minion is moving, so that's why it's in here. You know, I think it really helps me to be on stream doing this because I'm actually kind of walking the audience through what I'm doing, which is really interesting. Never really did this before. So initialization, search for enemy units, if no enemy found. Okay, so loop through all enemy units. So here's the code that decides whether we are within sight range, firing range, or just going towards the nearest waypoint. Nearest distance, nearest index, loop through all the enemy units. Check distance, distance, calculated. If it's a player, do that. If it's an enemy, do that. And it uses the different indexes based on, yeah. Check distance is less than sight range. Then check distance is less than nearest distance. Then we just narrow it down to the nearest one, nearest index. Outside of the loop, now check if one was in sight. Check here to see if the nearest enemy minion is within projectile range. Change state to firing projectile. Change set state, variable target minion. Calculate velocity of minion. Okay, so we're kind of... There's a lot here. Otherwise, calculate velocity of minion, parameters, prey, predator. So outside of loop, now check if one was in sight. See, this is projectile range right here. So if it's not within projectile range, then we do this. Calculate velocity of minion, parameters. So wait, is this... Oh, right, sorry, it does it right here. So here's minion sight range. Okay. I was going to say, we're getting ahead of ourselves, but no, we're not. So down here, and then it does that. So that does the waypoint. And then we're on to minion state 0, state 1. Okay, so let's just copy all of this code, I guess. And we'll narrow it down to what we actually need. We don't need that stuff. Okay, we need all of that, and we're just gonna cut it out. We're going up here to Minion state 0. Okay, so let's just It's all commented in, right? So let's post it. What does that look like? Too much. Okay, so this code does exactly what I wanted to do, but let's kind of comment it a little bit better and everything as we go. Nearest distance equals 100. GLUINT, nearest index equals 0, which we should set this at 100 as well. Because 0 is an index, that's a valid, like we don't want it to be that one. In fact, let's just make it a large number. Well, we could have 1,000 minions eventually. That'd be fun, wouldn't it? That'd be beautiful. Okay, loop through all enemy units. So this is moving to the nearest waypoint. Move to the nearest enemy if in sight range. So what we're really doing is loop through all the enemy units. So what we're going to do is check if we're within sight range or firing range of an enemy minion. And if not, move to the nearest waypoint. Okay. There we go. Okay. So in order to check within sight range or firing range of an enemy minion, and if not, move to the nearest waypoint. This is like 3 things in one. And we're going to throw in the avoid collision thing. Then so we've already got that uncommented. Oh, I didn't want to do this, but let's just go through and uncomment all this. Because it's code that works. There. Now, I think that's the reason for this squiggly there. Okay, good. So now I think everything works, but let's just go through this step by step. Loop everything. Check it all. So check if within sight range or firing range of an enemy minion. If not, move to the nearest waypoint. Oops, what's going on with this? There, that's going to look better. Okay, so first thing, loop through all enemy units. Okay. And then we can put this comment here. Okay, loop through all enemy units. I just don't want to make a mistake. I'm going really slow through this, but anyways, so check distance. And I don't want to leave these comments and just, yeah. Okay, check distance. So if it's a player, the distance will be 209 plus I, and will be the distance between 209 plus I's position and 219 plus J's position. If it's an enemy, it's going to be 209 plus I's position or 209 plus J's position, because the enemy is up in the array 10 more than the player, which is kind of weird, but it works. Okay, check distance. If check distance is less than Minion's sight range, so right here, so check if within sight range of an enemy minion. Okay, so we're kind of check if within sight range of an enemy minion. We're getting there. I like that now. We're getting rid of this code. Moves in its enemy if within sight range. Okay, so we got the if in sight range. Check distance is less than nearest distance. Minion has sighted an enemy closer than previously sighted, closer or the closest first enemy in sight. Okay, so it saves the index and it saves the distance. Let's just write this. This is the whole point of this loop, is right there. Because that will allow you to find the nearest enemy minion if within a preset sight range, which I set up top. I think it's like 4. So the minions will follow the waypoints until they come within 4.0, and to keep in mind a whole screen, either up or down or left or right, is 2. It goes from -1 to +1 and -1 to +1. So okay, so at this point we have, let me turn down the music in my ears. At this point through the loop, we have a minion definitely in sight, or we don't. If we don't, then near distance is still going to be 100. So if it's less than 100, we found one. Check here to see if the nearest enemy minion is within projectile range. So that is projectile range, see? And here's where we start to get into change state to firing projectile. Okay, so here's the difference. We're going to start to change our previous code right here, because when we're in state 0, move to the nearest waypoint, move to the nearest enemy, avoid colliding. If within firing range of an enemy minion, change to state 1. Okay. Oh, that's what we do. Set state variable target minion. Okay, this is going to happen, because what this is, the projectile velocity of the minion state is so we're setting the target for the minion. So let's go down here. So projectile state 1, set launch position, acquire direction toward target. So the first part of that is right here. So we're going to move this We're going to move this code. So the reason we're moving this code into the projectile state 1 is because we're moving the minion to state 1, which will activate the projectile state 1. So acquire direction from target. Use M state. Oh. Okay, so when we get to this point, we need to remember that nearest index. Which is actually okay because we're going through all these different states and everything. If we're in state 0, so nearest index is... Oh, it's defined just outside. So let's, nearest distance we can keep inside there, but nearest index we will declare just outside. Right there. Excuse me. So that puts the nearest index in the scope of this little loop here. So that makes that nearest index then available later on to that projectile state. So there we go. Acquire direction towards the target. Use mState gluent variable. So there's more to this too. Calculate direction toward target. So set target index into mState variable. Okay. All right. Okay. So we're getting there. This is great. Okay, we're moving that out of the minion's responsibility now. So here we are. So change state to firing projectile. And I feel good about that. What are you doing, computer? Okay, so if we're within sight range or projectile range, we do that. If we're not in projectile range, but we're here, we are within sight range. So we move towards the minion. Calculate the velocity of minion. Okay, parameters, prey, predator. Okay, so this can stay. This can stay. Okay, then we're outside the loop, or we're outside of the scope of that little if. Then we're good, then we're outside of the scope of the other if. So now we're all done with deciding what happens within projectile range or not. So within projectile range we set this. And then when we're in minion state 1, the projectile state will be set to 1. Okay, so we're good. Back to here. And so now we're in, again, we're within projectile range, we do this. If we're not in projectile range, then we set course to intercept the minion that we've sighted. And then if there is no minion in sight, then this else, head to the nearest waypoint, and then we do this. Next way, if it's a player minion, the next way is there. If it's an enemy minion, the next way is there. Waypoint is the prey, blah, blah, blah. Okay, so that takes us out of if one was found in sight, and if not. Okay, so then there's the else. Now we're in this loop again. We're back to minion state 0. Okay, so have we completed minion state 0? Okay, we don't have avoid colliding with other minions, because that happens in state 1. Actually, that's something to think about. Are we only going to do that? We can move that into... So determine rotation acceleration. Okay, check if we're in state 1, projectile. Okay. So down here in 2 and everything, avoidance. So here's the avoidance. If minion is too close to another minion, player, or enemy, then steer in the opposite direction. So here's all of the minions. It's cycling through all the minions. If the distance is less than that, then it adjusts the velocity to steer away. If K is not I, right. Okay, so so let's add this into the state 0. And then add velocity to minion position down at the bottom there. Okay, don't forget that, of course. Okay, so we're going to put this in state 0 for the minions. Right at the very end. Okay, so here is state 0. We're going to go down, 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 down. And that looks like a mess because we need to do this. Uh-oh. Oh, computer. You're absolutely killing me with this. Okay, so that's within, this is all state 0, okay? So avoiding colliding with other minions, we put that in. We have moving to the nearest waypoint, moving to the nearest enemy. If within firing range, change to state 1, we have all that in. Totally insane. Minion state 1 is completed. So we go through all that just to either move to the nearest waypoint, move to the nearest sighted enemy. If we're within firing range, we change our state to launch, which brings us to here. At launch, the state, we set the projectile to launch. We set the minion's velocity to 0, and then we change the state to 2. So then we're come down here, and then at stage 2, we're always checking if we're within firing range of an enemy minion. So we need to see if we're still within firing range of an enemy minion. And then here, if not, which we already do firing range of an enemy minion up here. See, check to see if the nearest enemy minion is within projectile range. So what we need to do somehow okay, and so basically we just need a function to calculate the nearest distance. Because, yeah, see, and nearest distance is just right here. It's all this code right in here. Right to there. Computer, you're killing me with this. But I like that. Okay, so if we can make this a function, how would we do that? Oh boy. We can make this a function, so all we need for this one is to send in the I variable, to send in the in-type AI, minion sight range is global, nearest distance is local, check distance is local. It will return either it'll return nearest distance. What's it going to return? Well, out of there we get two variables, nearest index, nearest distance. So are we going to make a structure that is returned just for this function? Oh, we can send in the variables by reference. We don't have to return a structure. That's a good idea. Okay, so let's make a function real quick because we're doing this down here. We're doing this at Minion state 2. We're checking if we're within firing range of a Minion. So with Minion state 0, we are using this function to check if we're within sight range. And then in state 2, we're checking to see if we're within firing range. So in either state, what we really want is the distance to the nearest minion and the index number of the nearest minion. Okay. Okay, nearest index is right there. Nearest distance is right here. So basically what I would put right here then is like this. Check for nearest. We would send in the I. We would send in the reference to the nearest index and a reference to nearest distance. So check for nearest. Let's see if we can do this real quick, just right here. It's not going to return anything because those variables are by reference. I have not done this very much. I forgot. See, this is why I like to have my functions at the bottom, so that when I'm creating new functions, I can put it right here. But it's just a small preference on my part. Not a big ish. Okay, so this is a void, and this is a gluent, as I like to say, and this is a reference to a unsigned integer, and this is a reference to a float. Or do I put pointer up here? Is that what we do? Are these pointers? I don't know how to declare these. Function declaration. Int where's the function definition? Am I missing something? Oh, here. Function definition. So you have to list the name of the variable. So in the definition, and it's with the little whatever sign. So here, no, that is right there. Computer, really? Did it just do that? Heck. Oh, and it just did that. Okay, that's weird. Check for nearest. Function definition now found. So it's the same variables and then put y into x, put x into y. Okay. What does this say? Declaration is incompatible with void D&D check for nearest. Declared at line 22. Show potential fixes alt enter. Or control plus. Oh, interesting. And then actually instead of I, let's use N-I. N. Okay, now what's the problem? Computer, I just did that. So is that because... Oh, a type specifier? Oh, well this is a glue type specifier? Oh, well this is a glue int. And this is a GL float. What's this? Does that work? Did we fix it? Do these have to be global? Are we freaking out? It's a void function. It doesn't do anything. It does a compile. Cannot convert argument 2 from glue int pointer to glue int. So when I call it, oh, we just throw in the variables. We don't use the address of, we just throw in the variables. Like that. Okay. Okay, we're all green again. So nearest index is set to 100, nearest distance is set to 100, and then we call the function. And then in the function we do this. Oh, right, we have to send it the in-type AI as well. Okay. As the last parameter, we're going to send in type AI. And that is an unsigned integer. So let's just change this variable. Okay, we don't return those. Now what? Oh, right. Okay, we're all green. Whew. So check for nearest. Now we're going to have to figure out if this works or not. Okay, the whole reason we did that is because check if within firing range. Okay, so down here in state 2, we need to call this function. So we're still in the I loop. We're still using nearest index, nearest distance. But we're in state 2, so the nearest index is going to be set. So we're also going to want to take this nearest distance. Let's just throw this outside here, and then let's just call the function again in state 2. Check if we're within firing range. So the only difference here is now we're definitely checking. We don't even care if we're within sight range because that's state 2's responsibility. So, if nearest distance is less than firing range, and that's right here. No, that's the avoidance. Projectile range. So firing range. Let's change this right here. Just like we had the other one, we have where'd that variable go? Minion sight range. So let's go minion firing range. So then down here, and then up here when we are looking for that, so if the nearest distance is greater than the minion firing range, then we are going to change to state. So then we're going to go this minion sub I dot m state. We're going to change back to state 0. That's an int, right? Yeah. Okay, so then we'll change to state 0. And that's okay if we're in the midst of changing. Excuse me. If we're in the midst of changing to state 0, check if projectile has reset to state 0. If so, launch the projectile. So potentially we could launch the projectile still in the same frame. However, that's going to happen so quick. It's like that means that the last frame we were within range of an enemy minion, and this frame we're not. And it's not really going to be far enough distance to notice, and it's okay if it launches at that point. So that's fine. Okay, we're getting there. We are definitely getting there. So now, projectile state 1. So we're done with the minion states altogether. That is a good feeling. Mostly just copying the code over, but boy, that took a while, didn't it? Well, I like to go through this and make sure that I'm actually doing it. Has it been an hour and a half? Good grief. Alright. So let's get minion state 1, minion state 2, projectile state 1. Okay, so set launch position and acquire direction towards the target. Calculate direction towards the target. Move along trajectory until we hit the end of the screen. If you hit the target or go off screen, reset to state 0. Okay. I'll be right back. Oh boy, that's good. Of course, I decided to get a cold drink. So here, let me put on my robe here, get a little more comfortable. Hold on. What are we doing? Okay, seems like we have a ways to go here, which is fine, but I am getting kind of hungry. For now, we'll just cut the music, not a big deal. Okay. It only seems like we have a long way to go. We actually don't, because I've still done a lot of this code already, so. Excuse me. So what are we doing? Setting the launch position. I'm not seeing the launch. Here's the rotation. Player particle position. Okay, so here's where we're setting the position. See, this is why I'm glad I'm doing this with particle, state, and yeah. Would you feel better with this? And then taking this and doing that? Does that feel better? Set projectile launch position. Okay, boom. Excuse me, I'm drinking orange juice and Mountain Dew. Excuse me. Okay, so acquire direction towards the target. Use the mstate glueInt variable. Okay, yeah, so the reason this works is that the 209 plus I position is where we're at the Minion. And then the 229 plus I position is the one that's being calculated. Okay. Let's make a note of that, I guess. 209 plus I. Because I know that very clearly now, but in the future I might not know that. Is current Minion index 229 plus I is current projectile for this minion index. Okay. Okay, so acquired direction towards the target. Okay, so how do we do that down here? Minion state 2. Aim at target, set laser projectile to corresponding minion rotation. Copy velocity to projectile. Okay. These two things. Set laser projectile to corresponding... Here, let me just uncomment this real quick. I'm just... Computer, don't... Okay. Which one of these are we doing? Or both of them, or what? Calculate direction towards the target. Acquire direction towards the target. Aim at the target. Set laser projectile to corresponding minion rotation. Okay. That doesn't aim at the target, that just looks at the target. Or it is the projectile, so it's aiming, I guess. Aim, look, whatever, okay. So that's the direction towards the target, it's the angle. Copy velocity to projectile. Alright. That was my... This is basically doing that, because we're calculating the direction towards the target, which is the velocity of the minion that we're currently at. But here, when we're in the projectile state 1, the minion velocity is set to 0. So by the time we get into projectile state 1, the velocity of the minion is going to be 0. So we need to do this before we set the projectile to state 1. And the rotation. So we're going to copy the rotation and the velocity in the minion state. Launch projectile. Set minion velocity to 0. So we want to do it right there before the velocity is set to 0. We want to aim at the target and then copy velocity to the projectile. Then set the minion velocity to... So we weren't done with the minion state 0. Okay. Oh, yeah, that's fine. I'm just, yeah. Set laser projectile to corresponding minion rotation, copy velocity 2 times to the projectile, and then set the minion velocity to 0. So, yeah, because the velocity is set to 0 right here, we'd never want to do this again for this particular projectile. So then we'll just immediately switch the minion to state 2, which will continually loop and launch the projectile, or switch back to state 0. Okay. So then set target index into state variable here. Did we do this right? Nearest index. Projectile velocity state 1. So that, but this nearest index, that is calculated in minion state 2. It's also calculated in state 0. It's not really calculated in state 1. So what I was doing was, this is just generally in the code. Okay. Why I was doing that. Well, we already have the velocity to follow no matter what, so we don't really need this. We don't need this. And the calculate direction, acquire direction, that happens in another minion projectile state, so we don't need that. So this state, all it does is become visible and set the position. That looks great. And then it changes the state 2. And minion state 1 actually does some stuff for the projectile here, so that's good. Okay, we're almost there. We are almost there. So now, move along the trajectory until it hits... Okay, so we already move along the trajectory. This minion state 2, set minion velocity. Excuse me. Okay, here's the final bit. The final bit. Excuse me. Finally wised up to what Visual Studio was doing. Not sure why, but anyways. Okay, so move along trajectory until it hits the target or goes off screen. So that is this right here. Add velocity to the laser projectile. Let's just keep this as a general. Okay, if it hits the target or it goes off screen, reset to state 0. Okay, so previously I just check if it hits the target right here. Are we there yet? Okay, impact. We're not going to affect the minion anymore. And if we do get impact, we're just going to set the velocity, or the projectile velocity state to 0. Oh, I forgot we already did that, but we also are missing a step. So let's set it invisible. We set to state 0. Invisible. And we don't care if it's moving or not. So add velocity to minion position. So we do that inside this loop. As, of course, the very last thing to do. Does that make sense? Is this inside the loop, of course? It's for all the minions. Okay. Does this compile? Does this work? What? It's working. Huh. Oh, we don't check if it goes off the screen. That's okay. We'll see what happens if we... Oh, look at that guy freaking out. Okay, so let's... So reset the projectile. See, we did leave some stuff here. If it hits or goes off screen. Okay, so this calculates if it hits the target. But we didn't calculate if it goes off screen. Of course, I didn't see any of them reset. Oh, wait. They did reset, but they went invisible. Go invisible and wait for the minion to fire it again. Did they go invisible? First of all, I'm surprised it even compiled. I'm surprised it even worked. So let's just see what these guys do. This is really cool. Okay, none of those particles reset. These guys kind of freak out a little bit. Not sure why entirely, but that's okay. So none of the particles go invisible, so they don't actually get to this point. Projectile velocity M state dot position. So what if we so if the particle goes to state 0, see, it checks for state 0 here. They should all be in state 2, so it's just going to continually check if it's in 0, and it'll set it to state 1 if it is. But I should see them go invisible, but they don't. Oh yeah, let's change this too. Hold on. Still not going to do it. And then we should do, because it's not checking to see if the projectile comes within range of the enemy. See? Looks like they actually hit. It looks like they actually hit. But they don't, it doesn't actually register that it hits. Okay. So are we there yet is never there yet. So I know we're going to get 20 responses the whole time, but let's just... How many minions do we have? Yeah, let's just do if I equals 0, printf. We just want to print this. So every frame will get that. If once the projectile gets into state 2. So we shouldn't have any at this point. We don't. Okay, good. I just want to see the are we there yet as it goes through, and once it passes the other minion, we'll stop it and see if we can. Oh. Wait, how come it starts so close? 090 and it just gets further and further. Oh, is it is it Wait a minute. Projectile vel 1 M state. So oh, because we're using M state. Previously we were not using it. That's a problem. We're just adding a variable. Target index. So right here, this is incorrect. And we can set it, aim at target, set laser projectile to corresponding minion rotation. So the target, we know it up here. Okay, once we check for nearest is there. Okay, change state to firing projectile. So click here to see if the nearest enemy minion is within projectile range. So right here is where we get it. It's the nearest index. See, the velocity is aiming towards the nearest index, but we never use nearest index instead. Okay, so if it's less than firing range, fire. Otherwise, okay, it's aiming towards it right here. So this, oh wait, no, it's projectile velocity sub I dot target index equals nearest index. So is that nearest index, or is that nearest index is J, so the actual target index is equal to the actual target index is actually going to be equal to, well, if it's AI 0, the target index is going to be 219 plus J. And if it's 1, okay, so we need to save these. Hold on. True. There we go. So now target index. So now we're just going to use this down here. So now we'll probably get the recycling because the state set to 0. That everything else is correct. We may actually see this work for the first time. I had that incorrect the whole time. That's why I was having all these problems. I was missing just one thing. There you go. They did reset, and then, okay, so now they went invisible. So also, I just am now thinking, so when we switch the state to 0 here, we also need to make them invisible. Or make them visible, because if the particle state is 0, we set it to 1, and when it sets it to 1, oh, it makes it visible. Computer. So why doesn't that work? Alright, temporarily, let's just try to set this to 1. See what happens. And not make him invisible. So it'll say the same color. Oh, sweet. There we go. That is the ticket. Okay. So, for some reason, setting the state to 0 and setting them to invisible doesn't work. Because what? The minions are glitched? For now, that works, so I'm going to keep it. Alright, hold on. Hold on just a second. This is just a little hilarious at the moment. Let's close that window. Go over here. Let's play my favorite one from here. What downloaded, by the way? Oh. Bum, 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 bum. Hold on, hold on. What? Computer. I said hold on. What the heck? Oh, that starts it again. Okay. Boy, they really need to work on the, you know. Anyways. Oh, Cosmoteer. Nice. Space Menace. Planet Crafter. All good. Good, good, good. Stardew. Nice, dude. Okay, actually, while that's updating, I'm pretty sure we can still run the music player. So let's just... Oh, so we got that. Okay, so let's... Oh, good. Now I can clear all that and minimize that and leave this up. Okay, so here we go. Right on. Bum, 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 Well, thanks for tuning in, everybody. I'm ending the stream now. That was really good. We got it to work. Next step is to make it, what, pretty? Clean up the jolts, clean up the